Hello, this is the fourth video in a series of four for Chemistry Paper 2, and this one is called Chemicals in the Atmosphere, and looking at how the chemicals have changed over time, looking at the greenhouse effect, looking at the impact humans are having on the atmosphere and the changes in gases, carbon footprint and sustainable development. So we're going to start off by looking at the Earth's atmosphere and looking at what it was like, we think, originally and what it's like now. Now, we say originally because obviously there were no humans on the Earth 4.6 billion years ago when the Earth was first formed. However, we do believe that there were many, many volcanoes on the Earth, and that helped to change the percentage of gases in the atmosphere quite significantly. Now, what you've got to remember is these processes took millions and millions of years to actually take place. So it's not like there was one quick volcano and it gave out some carbon dioxide and water and then all of a sudden we've got an ocean. We're talking millions and millions of years of this taking place. We think originally that most of the atmosphere on the Earth was carbon dioxide. And when the volcanoes were giving out all the molten lava, it was also giving out water vapour. And we think that's how water vapour started to get into the atmosphere. We also think that there were small amounts of methane and ammonia in the atmosphere. However, if we look at the percentages that we have today, nitrogen is 78%, oxygen is 21%, carbon dioxide has gone right down to 0.04%. And that's the important thing to remember. Most of the atmosphere originally was carbon dioxide to now where it's 0.04%. Whereas in the beginning there were very small amounts of nitrogen and that has gone right up to 78%. Now you might be asked, well, how have these changes taken place? Because originally we didn't have any oxygen and yet now we've got 21%, which is enough for us to survive. How did these processes take place? Well, we think that originally when the water vapour was given off from the volcanoes, that then condensed down to make the sea. And as the sea condensed into water that was collected on land, that the carbon dioxide dissolved into it. By doing that, the carbon dioxide also then helped to form rocks. And again, that took in the carbon dioxide. We think that, and this is the bit that we are not 100% sure of, is what were those first organisms of life on this earth? And it's where that came from that is really debatable. Some scientists think that some kind of reaction took place to start some kind of living cell-off. Some scientists think that some meteor came from outer space and hit the earth with microorganisms on the rock, and that started off life on earth. But we just don't know. However, through evolution, we ended up making small green plants. And they would take in carbon dioxide and give out oxygen. And it was this main process that caused a big change and a big shift. We had a lot of carbon dioxide took in through the rocks and the sea, but this one actually meant that they were taking in the carbon dioxide, but actually giving out oxygen, which is what's needed for living organisms to carry out respiration. We also believe that bacteria are responsible for the amount of nitrogen in the atmosphere, because when organisms die, the decomposers, actually the bacteria, break down those dead organisms and release nitrogen gas into the atmosphere. And that must have been a lot taking place for us to get up to like 78%. Okay, so the Earth's atmosphere has changed, and the thing you've got to remember is this is the Earth's atmosphere as we think it is today. But when we're talking about the greenhouse effect, we're talking about other gases because we're just talking about one process. This is the whole atmosphere. If we go to look at the greenhouse effect is just looking at 3 different gases. So you've got carbon dioxide, methane and water vapour. And these are responsible for, like I say, this greenhouse effect. Now if you think about a greenhouse, it's covered in glass. And when the heat hits the glass, the heat goes through the glass into the greenhouse, the heat gets trapped and can't get out. And you think to yourself, well, how does that happen? And the reason it happens is exactly the same for what's happening on the earth. As the heat energy leaves the sun and comes down to the earth, you can see it's a short wavelength. That means it's high energy, and that comes through our atmosphere of carbon dioxide, methane and water onto the earth. And some of that heat is absorbed by the rocks or the plants or the sea, whatever it is that's absorbing some of that heat. And because some of it's absorbed, we then end up with a longer wavelength because that's got less energy. Some of that heat then goes back through the gases out into space, and some of it actually gets trapped, just like the greenhouse, it gets trapped into the earth. And it keeps our earth at a temperature that is warm enough for us to survive on. The problem we've got is, and this is all in the news at the moment because it's a massive issue, is we are releasing more and more carbon dioxide into the atmosphere and more methane into the atmosphere, and these layer of gases are getting thicker and thicker. So the high energy short wavelength can get in, but the long wavelength low energy can't get back out. So more and more heat is being trapped into the earth, and so the ice caps are melting, so water levels are rising, weather patterns are changing, and all sorts of different effects that we're having. Now let's have a look at the human impact on the earth. There are several things you could be asked about here. When we burn fossil fuels, so we dig up the fossil fuels, crude oil, natural gas and coal, and we burn them to get the energy. But by doing that, we're releasing more carbon dioxide. So we take crude oil, we get the petrol from the crude oil, we put it in our cars, the cars then make more carbon dioxide. Deforestation. Every time we cut down a forest, we are releasing that carbon dioxide back into the atmosphere because the trees and the plants had actually stored that carbon dioxide away. Landfill sites. When rubbish is rotting down, it produces methane. And that's a huge problem because it means we're contributing more methane to the greenhouse effect. More animal farming, because we've got more people to feed, means more methane. More carbon dioxide just means more global warming, because now we're still contributing more and more to these gases here and making that layer thicker so the heat energy can't get out of the earth. Now, if we look at what does carbon footprint mean, your carbon footprint is the total amount of carbon dioxide and any other greenhouse gases that are emitted over the whole life cycle of a particular product. So for instance, windmills. We are using more and more windmills in the countryside to actually use as a renewable source of energy, because we use the wind to turn the turbine, which turns the generator to generate electricity. The problem is, somebody's calculated that we actually produce more carbon dioxide by actually making the windmill in the first place than it actually ever gets back in its whole lifetime. So that windmill is leaving a carbon footprint on the earth, even though it's probably smaller than a lot of other products, because it is actually helping to save some carbon dioxide being released as well. So how can we reduce our carbon footprint? We can use alternative energy, as I just said, wind turbines. We can carbon capture and store, so plants, tree planting, they capture carbon and actually store it away. Or we can choose carbon neutral products. So anything, so biofuels for instance, we usually call carbon neutral because the amount of carbon dioxide they take in is the equivalent of the amount of carbon dioxide they actually give out. So we call that carbon neutral. If we look at sustainable development, this is something that we really need to pay attention to, because this is all about whatever we take out of the earth, we need to make sure that we're putting back in. So, for instance, every time we cut a forest down, plant new trees. Every time fishing takes place, we need to make sure we don't overfish in the seas. So there are quotas now that fishermen can only catch certain amounts of fish, and they can only catch them if they're over a certain size. So someone I spoke to the other day that's a fisherman said he catches bass, and if the fish is below 42 centimetres in length, it has to go back in the sea, because otherwise it's not old enough to breed and to replenish the stocks. He told me a story about someone that did still bring in the smaller fish, and they actually got caught and fined about £5,000 for it, because it's that important. Also, recycling metals. We've only got a certain amount of metals on the planet, so we need to make sure that we keep recycling them so that we can use them for other products instead of just trying to find more in the planet that we have. If we move on to water then, water is another one of those products we sort of take for granted a little bit. And in some countries they actually call this liquid gold, because they just really can't get fresh water. 80% of our earth is covered in water, but it's all seawater and it's inaccessible because it has to go through a process of desalination, of removing the salt. And that's actually quite a complex process and takes a lot of energy, and nobody's actually come up with a way yet of doing that cheaply. So we have to rely on our fresh water. Now, if we're talking about drink water, we call that potable. Some people say potable, which is good quality and is safe to drink. However, it is not just pure water. It's not just H2O. It's got chlorine in it, which helps to kill microbes, and it's got fluorine in it, which helps to reduce tooth decay. So, how do we get potable water? We have a fresh water source, which is filtered, it's chlorinated, and then it has fluorine added. The other type of water is sewage water, and that has to be treated before it's put back into our waterways. So screen and grit is removed, sediment is removed, and then a biological treatment to get rid of any of the parts of the water that are disease, that can cause disease. So there's two types of water there, but there are several types that you could talk about. Life cycle assessment I sort of mentioned in a previous video. So when we are thinking about a product and we're thinking about making sure we are not having too much of an impact on the earth, we need to think about how can we get those raw materials? What's the design and production of the product going to be? What about the packaging and distribution? So if we're like making a product and then shipping it to the other side of the world, we're actually contributing to the carbon footprint by the travelling carbon dioxide coming from the petrol or diesel. The use and maintenance of it, the reuse and recycle, can it be recycled or reused? And then lastly, the disposal of it. Can it be disposed of safely? Can it biodegrade and break down? All of this has to be taken into consideration when we're carrying out a life cycle assessment. And you could be asked about any product here, and you need to think about the whole process. Now, if you're doing the foundation tier, you can turn the video off now. If not, you're doing higher tier. There's just two more little things I just need to mention, and that's these two. This is a new thing that's coming to the GCSEs, and it's asking about how I can extract different metals, but this is only tiny amounts of metals. So you've got this thing called phytomining. It means the plant absorbs copper, the plant is then burnt, and then we can collect the copper. Tiny amounts, but still important. And lastly, bioleaching. For this, we can use bacteria in a solution. The bacteria convert copper in the solution, and then we can extract it. And that is the last video, 4 parts for chemistry paper 2.